People sometimes ask me how I learned to think the way I do. They assume there's some secret, some trick I picked up somewhere. But the truth is, I don't think I'm particularly smart. What I did learn, though, and this took me years to figure out, is that most people don't actually think. They just accept. Let me tell you what I mean by that. When I was a boy, maybe 10 or 11 years old, my father used to take me for walks in the Catskill Mountains. We'd walk through the woods and he'd point at birds. One day he'd pointed at a bird and said, "See that bird?" In Italian, it's called a ciutola lapida. In Portuguese, it's bombed. In Chinese, it's chung longta. Then he'd pause and say, "No, you know in all those languages what that bird is called, but you still don't know anything about the bird. You only know what people call it in different places." Now that bird, if you watch it, you'll notice it's always pecking at its feathers. Why? Because there are lice that eat the protein in the feathers, and the bird has to clean them off. The lice eat the protein. They lay eggs. More lice come. The bird spends half its time just staying clean. That lesson stuck with me my whole life. Knowing the name of something is not the same as knowing something. And most of what we call education is really just learning names, learning labels. But thinking real thinking means asking what's actually happening. I noticed this later when I was at MIT and Princeton, sitting in advanced physics classes with some of the smartest students in the country. We'd be learning about, say, quantum mechanics or electromagnetic theory. The professor would write equations on the board, beautiful equations, and everyone would copy them down carefully into their notebooks. And at the end of every class, without fail, some student would raise their hand and ask, "Professor, what does this equation mean?" And the professor would turn back to the board and write the same equation again, just with different letters. And the student would look down, nod, and write it in their notebook, satisfied. And I'd be sitting there thinking, wait, that's it, that's the answer. Because my question wasn't, what does the equation say? My question was, what is actually happening out there in the real world that this equation is trying to describe? Those are two completely different questions. And almost nobody was asking the second one. See, there's a gap, and it's a big one, between knowing something and actually understanding it. And the scary part, most people never notice the gap is even there. They can repeat what they were told, word for word. They can pass the exam, get the grade, use all the right terminology, and they genuinely believe that means they understand, but they don't. Let me tell you about something I saw up close. After the war, after Los Alamos, I went down to Brazil, taught physics at the university in Rio Beautiful City. Warm people, students who showed up every single day with their notebooks open and their pens ready. Serious kids, motivated kids, and they were incredible at memorizing. I mean, they could recite entire textbooks back to you, chapters, definitions, derivations, all of it. So one day I stopped the lecture and asked a simple question. What happens when you shine light through a Polaroid filter at a certain angle? Silence. I waited. Nothing. These were students who had read everything, who had passed every test, but they'd never once stopped to think about what any of it actually meant. So I tried a different way. I said, forget the textbook for a second. You're at the beach. Sun's out, you look at the water, and the reflection is almost blinding from certain angles, but not others. Why? More silence. And that's when it hit me. It wasn't that these students were lazy or careless or not intelligent. It's that nobody had ever asked them to think, only to remember. And there's a massive difference between those two things. Which brought me to something I've believed ever since. Thinking is not something you're born knowing how to do. It's something you have to actually learn. It's a habit you build. And most people never build that habit because nobody teaches them how. So, how do you build it? How do you train your brain to actually think instead of just accept? The first thing I learned to do, and I did this naturally as a kid without realizing it was special, was to always translate what I was learning into something I could see or touch or imagine. When someone told me about atoms, I didn't just memorize atoms are small particles that make up matter. I'd picture them. I'd imagine them bouncing around, colliding with each other. I'd ask myself if I had tiny eyes and could watch atoms, what would I see? Later, when I was studying physics at MIT, I did the same thing with equations. People thought I was slow because while they were racing through problem sets, I'd sit there, sometimes for hours, just staring at an equation. But I wasn't being slow. I was translating. I was asking myself, what is this equation actually describing? If I could watch this happen in real life, what would I see? Sometimes I'd even invent strange little scenarios. Like when I was learning about electromagnetic fields, I imagined I was the size of an electron floating in space. What would I feel if another charge came near me? How would I know? What would push or pull on me. This sounds childish, maybe, but it worked because once I could see it in my head, I understood it. And once I understood it, I never forgot it. Here's the thing. Nobody tells you. If you can't picture something in your head, actually see it happening, you don't understand it. You just know what it's called. And that's the trap most people fall into. They start with the abstraction, the formula, the technical term, the theory. And they never, not once, stop to ask you, okay, but what does this actually look like in real life? So it just sits in their head, floating, disconnected from anything real. And then they wonder why they forget everything a week after the exam. The second thing I had to learn, and honestly, this one took me much longer, was to never stop asking why, not once, not twice, over and over, like a little kid who doesn't know when to quit. Because here's the thing about kids, they're actually brilliant at this. You tell a 5-year-old the sky is blue because of the way light scatters in the atmosphere. They don't nod and move on. They say, okay, but why does light scatter? You explain air molecules. They say, why do the molecules do that? You explain wave interactions, they say, but WHY? And eventually, if they keep pushing, you hit a wall. And you have to admit, I actually don't know. That's the real answer. That's always been the real answer. But somewhere between childhood and adulthood, we stop asking. We get embarrassed. We don't want to be the person in the room who asks the question that sounds too basic. So we nod, we smile, we pretend, and that's a disaster. Because if the foundation is shaky, if there's a gap in your understanding right at the bottom, everything you build on top of it is shaky too. I had a student at Caltech once, bright kid, came to my office looking genuinely frustrated. He said, I don't understand the uncertainty principle. I said, all right, tell me what you think it means. And he started talking, position and momentum, Planck's constant, the mathematical relationship between them, word for word from the textbook, perfect delivery. I held up my hand and stopped him. I said, no, I didn't ask what the book says. I asked what you think is actually happening. He stopped, looked at me, and went completely blank because he'd never thought about it. Not once. He had memorized an explanation without ever asking what it was explaining. He literally couldn't tell me because he'd never thought about it. He just memorized it. So we sat down and I said, let's start simple. Forget quantum mechanics for a second. If you wanted to measure where something is like a ball, what would you have to do? And he said, look at it. And I said, right. And how do you look at something? And we went through it. Light bounces off the ball, enters your eye. You see where it is. And I said, now, what if the ball is really, really small? So small that the light you use to look at it actually pushes it when it bounces off. And you could see his face change. He got it. Not because I gave him a better definition, but because he finally thought about what was actually happening. This is the secret, if there is one. Don't accept anything until you can explain it to yourself in your own words, using your own pictures, your own analogies. If you can't do that, you don't understand it yet. And that's okay. But don't pretend you do. The third thing, and this is maybe the most important, is that I learned not to be afraid of not knowing. This sounds simple, but it's not. Most people are terrified of admitting they don't understand something. They think it makes them look dumb. So they fake it. They nod along. They use the right words even though they don't really know what those words mean. But here's what I figured out. The smartest thing you can do is admit when you don't know something. Because once you admit it, you can start actually learning it. But if you pretend you already know it, you're stuck. The moment you pretend you understand something, your brain thinks the problem is solved. It stops working. It moves on, and you're stuck. I used to sit in seminars at Princeton, at Caltech, big rooms, famous physicists at the front, talks so dense and technical you could feel the weight of them. And I'd look around the room, and everyone would be nodding, slow, confident nods, like, yes, naturally, of course, obviously. And I'd be sitting there thinking, I have no idea what he just said. So I'd raise my hand and ask something basic. Sometimes people would glance over at me, that look, like, why is he asking that? Isn't it obvious? But then the talk would end, and I'd be standing by the door, and someone would walk up to me quietly. Thank God you asked that. Then another person. I didn't understand it either. Every single time, because here's the truth, and nobody really wants to say it out loud. A lot of what passes for expertise is just a very convincing performance. People learn the vocabulary. They learn which words belong in which sentences. They learn when to nod and when to look thoughtful. But ask them to sit down and explain the core idea to someone who's never heard of it before. And they fold. They go right back into the jargon. They make it sound more complicated. They add more layers. because they themselves are lost, and complicated sounds smarter than confused. So I made myself a rule. If I can't explain something clearly to a student, to a kid, to someone with zero background, then I don't actually understand it. I just think I do. And those are two very different things. Now, the last thing, and I'll warn you, this one might sound a little strange. I learned to actually enjoy not knowing something, not tolerate it, not make peace with it. Enjoy it. Because that feeling, that moment when something doesn't quite make sense, that's not a problem. That's a door. During the war at Los Alamos, we worked constantly. Long days, high pressure, no room to breathe. In physics, the thing I'd loved my whole life had started to feel like a weight, like an obligation, like a job. Just equations and deadlines and pressure. So when it was over, when I got back to Cornell, I made a decision. I was done trying to do important work. I wasn't going to chase the next big result. I wasn't going to think about publishing or whether any of it mattered. I was just going to play. Think about whatever seemed genuinely interesting. Follow whatever thread felt curious. No agenda, no pressure, nothing to prove. Just play. I was just going to think about whatever seemed interesting. And one day I was in the cafeteria and some kid threw a plate in the air, and I noticed the plate was wobbling as it spun, and there was a blue medallion on the plate, Cornell's logo, and I noticed that the medallion was rotating faster than the plate was wobbling, and I thought, I wonder why. So I went back to my office, and just for fun, I worked out the equations. Why does the plate wobble that way? What's the relationship between the wobble and the spin? And it turned out to be connected to some deep principles of rotation and angular momentum. And that little problem, that silly thing I did just because it seemed fun, eventually led to work that contributed to my Nobel Prize years later. But I didn't know that at the time. I wasn't trying to do important work. I was just playing. I was just curious. And I think that's maybe the real secret, if I'm being honest. You don't force your brain to think like a genius. You just let yourself be curious like a child. You ask questions. You try to see what's really happening instead of just accepting what you're told. You admit when you don't understand something, and you keep thinking about it until you do. Most people stop themselves before they even start. They think, oh, that's too complicated for me, or I'm not smart enough to understand that, or I'll just trust the experts. But understanding isn't about being smart. It's about being persistent. It's about caring enough to actually think about something instead of just accepting it. I've spent my whole life around the smartest people in the world. Nobel Prize winners, brilliant mathematicians, incredible physicists. And you know what? Some of them were genuinely brilliant. But most of them were just people who never stopped asking questions, who never accepted something just because everyone else did, who kept thinking about problems even when everyone else had moved on. You can do that. Anyone can do that. You don't need to be special. You just need to care enough to try. So, next time someone tells you something, anything, doesn't matter what, don't just accept it. Ask yourself, what does that actually mean? Can I picture it? Can I explain it to someone else in my own words? If not, then I don't really understand it yet. And that's okay. That's just where the thinking begins.